we want to instantiate this component here. You got something called cb2 cls post 0, which is a component of cb2 ce blsd. And in here we want to add a port map for them, and between the round brackets we actually want to paste all of those again. Can get rid of this. So in here we need to port map them to something. So switch, our inputs will be port map to switch and up will be port map to the slave register 0, and the signal count will actually be our output. We're gonna port stuff to 2 different bits, one for the counter, one for the chip enable. Here we have clock and reset as well, but we have to use the same ones as the entire program is using, so we're just gonna scroll back all the way to the top. You see X as slave underline XII a clock. Copy this. This is where you're gonna port map your clock, and your reset will be S underscore XII underscore a reset in, if I'm not mistaken. Just let me double check here on the top. Yeah, that's it. The thing about this reset on the board, it's actually asserted on 0, and our reset is actually asserted at 1, so we need to invert this connection, so we put it not in front of this. So after you've done that, you just finish instantiate your component, but what you will be needing to do right now, it's make something with this signal count here, because it's just a signal, it's not doing anything. So if you scroll up here, you'll see this process, and he's actually putting your register data output to some of the registers. So here, get rid of slave register 1, and we're gonna add sig underscore count. And in here, make sure you change this on your sensitive list for the project as well. So signal underscore count will be here too. So save this right now. I'm gonna save this one as well. You see the hierarchy update every time that you save your file. So if you look right now, you should see that the 3 files are a branch of the branch file here. So before I finish everything here, just gonna run the synthesis, see if I got any errors that saving the project won't be detected by vivado. Pretty much what I'm checking right now is that I don't do any error, which is not a syntax one. So no errors here, synthesize is completed. So go back here to your package AP. You see file groups here, you get a merge changes from file groups wizard. You're gonna make sure this is a green tick like this. And in here we're gonna change the display name for version 1.0.1 and the version as well. You can add a description if you want. So this is the software controller cb2 ced IP block. So we're gonna review and package. This is how you're gonna be displayed. This is your description. Just package your IP now. And vivado will ask if you want to close the project as well. So hit yes for here. So we're gonna go back to the other window of vivado. See, he runs something on the background, so kind of closes. You kind of freeze this window. You won't be able to do anything until the closing project edit something. It's done. So in here we want to create a block design to implement everything on the board. So here we're gonna add a zinc server processing system. Gonna run block automation. We want to add as well an Nexi GPIO, and we want to add our brand new CB2 CED software control. You can run the connection automation, get the access. Now we're gonna regenerate our layout, go for boards, get the LEDs attached to the GPIO output here. So go back to sources, right click here, create a HDL wrapper and the vivado wrapper and auto update. Once this is done, you're gonna save your block design and you're gonna run your bit stream. So right now it takes a little while. I'm just gonna pause the recording right now, and when the bit stream is done, I just go back to this. So the bit stream generation is completed right now. We're gonna open implemented design, export hardware, and launch the SDK. So file, export hardware, include your bitstream, file, launch the SDK. So in the C program that we're gonna use here, we actually have to instantiate a GPIO again, something that we've done in the first project. I won't be covering this again. If you need more details, just go back to video 1. So in here we want to create an application project called Zybo underscore CB2CED underscore software underscore control. You're going to create a BSP as well. So get hello world template to work for you. Everything generated again. So open your folders, src, hello world. And right click here, run as, go for run configurations, and here double click here, you're going to create a new one, go to studio connection. Yeah, I need to check this. Okay, it seems like my, yep. So com5, okay. Just try to right click here now and run as, go for run configurations. You see the Zybo CBG here, go for studio, connect studio, make sure your baud rate's correct as well, apply and close. So in here, right click this, run as, and launch on hardware. You're gonna see the connections are doing good, because the first time that it didn't work was because the Zybo was connected to the PC, but it wasn't powered on. So this kind of stuff could happen to you. Press studio not connect to the console. You see here's on the terminal, hello world. Okay. So right now we're gonna right click here. We're gonna change the run configurations again. And apply this. And we're gonna edit the code for hello world application now. This video is quite long, so I'm gonna cut in now and do another one explaining the code here and illustrating the results on the console.